Muhammad Ahmed is saying, sir, I saw you from my YouTube. Shafiq is saying, saw you from your YouTube. My math teacher told me about you. That's what Ahmed is saying. Awesome. I got to know you from my brother's friend. Oof, the chain is just awesome. I love it. I love it. I love each other. Okay, guys, one more thing. Do you know a fun fact? I love teaching new generation. I love teaching newbies. Do you know why? Because the the more I interact with new kids, the more I learn about what the future is going to be of this country. And to be honest, there's something that I'm noticing in this batch. You are quite a few kids in this classroom, and there's something that I'm noticing, and that's really, really good. I love it. Most of you are talkative. I love a talkative batch. I've been saying this since the day I started teaching. I love students who talk, who ask questions, who ask just gajillion questions relating to whatever, right? But during the class, just ask class related stuff and fun facts and whatnot. But outside the classroom, you can ask me any question you want, any query that you have, anything you need help with and whatnot. Let me also make a smiley face. Wee. So that's the thing. I love you guys. I love you guys for talking in the classroom, because usually what happens is that the summer batch is very boring. It's very dull and boring. And the reason for that is, in the summer, students don't want to study. It's like, oh my God, my mom is forcing me to take this session, da 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 da. But now students are realizing that it's now or never. You guys also have to focus on making small businesses, becoming little entrepreneurs and doing fun stuff. So that voice is so funny. That's actually the voice of, tired teenagers. Tired teenagers fed up with their parents. Oh my God, mom, you're forcing me to take class again. Teachers from my school got annoyed because of questions, lol. Arush, kill them. No, I'm joking. Please don't kill them. Please don't kill them. I do not condone any of this action. Any of this type of action. Sir, you should try acting. Aina, I think I'm pronouncing your name wrong, but I also got offered to model for a brand back in the day, but obviously I can't do everything, so I rejected that offer. It was modeling for a West. I was like, I ain't modeling for a West. You'll be taking my murder charges though. I love our talkative class. This is the first summer's class that is talkative. In 6-7 years of my teaching experience, this is the first summer class where most of the kids are talking. I love this. Did you watch Squid Game? No, Mustafa. I watched the first season only, and then not the other seasons. Isha is saying, bro, what? What do you mean? Are you guys saying that to Mustafa? Bro, what, bro? You should have done it. Phir we would brag. Our chemistry teacher is a chartered accountant and he's also a model. I don't know. I can't do everything, yaar. मैं थक गया हूँ. चलो जी, चलो. अच्छा, गपशप बहुत हो गई. I have to go back to work as well. Hello, sorry for my bad English. Okay, let's start. So yesterday, let's start, guys. Let's come to the class and then we'll do gupshup at the end, right? So yesterday we started off with a basic introduction to chemistry, and we said that chemistry, if you talk roughly about chemistry, it's all related to the concept of an atom. And the way we defined an atom was that an atom is the basic unit of matter. And remember, this definition is absolutely flawed, but for your course it will do the job. When we go further in your course, I will correct this definition, but for now let's understand that an atom is the basic unit of matter. And what is in fact matter? Matter is anything which has a mass and occupies space. So effectively, if you look at yourself, you have mass, you occupy space, you're matter. If you look at the laptop, the keyboard, the iPad, the mouse, the table, the chair, everything that you look at has a mass and occupies space. Therefore, it is matter. And the teeny tiniest particle, which I call the basic unit, which makes up matter, that's called an atom. Yeah? We all made sense of all of this stuff. And obviously, no, feelings are not matter, because although they might take up space in your teeny tiny, sensitive brain, but it's not matter because it does not have mass. It can't be quantified. Quantified means you can't give value to it, right? So that's not mass. And then we realized that nowadays, in your universe, you actually have uncountable atoms, billions, trillions, quadrillions of atoms. Even in a single human body, you have about 2.14 into 10 raised to the power of 21 atoms in a single human body. That's 2.14 sextillion atoms. So many atoms. But at the beginning of time, at time equals 0, when the universe was being made, there were no atoms, 0 atoms. What happened? There was a explosion 13.8 billion years ago. There was a beautiful explosion that resulted in atoms being formed, that resulted in particles being formed, which was protons, electrons, and neutrons. And then these protons, electrons, and neutrons combined together to give you the atomic structure, to give you the first atom, which was the atom of hydrogen. That's why hydrogen has one. The hydrogen has the number 1 in the periodic table. That's one of the reasons why hydrogen has the number 1, because it was the first element to be made after the Big Bang happened, right? And you realize that this roughly happened about 380,000 years after the Big Bang. The first few minutes after the Big Bang, these particles were made, and then these particles were clumped together over the next 380,000 years by gravity to give you the first atom. And then these atoms fused together to give you helium and traces of lithium. But we realized that not all the atoms were made because you did not have enough energy. So what happened was that these helium, lithium, and hydrogen atoms, they combined to give you stars, giant balls of hydrogen and helium gas. And then what happened was that these stars reached their death, which we call what? Which we call supernova. There was a huge explosion, and this explosion had enough energy to give you all the other atoms that you see in your periodic table, the 92 elements that you see in your periodic table. Can you explain why we are 13.8 billion years old? The reason why we are 13.8 billion years old, Hawa, is because when the stars bursted, it gave you all the atoms that makes up a human body. These atoms were in fact the only atoms that were created at this point in time. And after this, no atoms were created. So the universe, the atoms, your body, everybody's bodies are made from the atoms which came as a result of the death of stars. Because largely speaking, your human body has these elements: carbon, oxygen, nitrogen, some traces of sulfur and whatnot. When somebody's fart stinks, that's because they eat sulfur content. They eat a lot of onions and whatnot. Sorry for being disgusting, girls, but I'm just saying, if that's what happens. I'm not even joking. If you eat sulfur food that contains sulfur content, your farts are gonna stink. So yeah, atoms cannot be reproduced again. These were the only atoms that were made at the time of Big Bang. That's why you study, Hawa, that atoms can neither be created nor destroyed, because you can't have that much energy now to fuse these many atoms. You can't have that much energy. These were the only atoms that were made. So you said yesterday that you are not going to go into the detail because our brain can't absorb it. Will you go into detail today? No, Kashif, today we are going to officially commence with O-level IGCSE. Done, sir? Okay, great. Okay, this was just a recap of what we had done. Now, let's come to the first chapter, which is States of Matter. That's the first chapter written in the syllabus, opened right in front of me. What does this mean? What does this chapter mean? If you look at this chapter, it says States of Matter. Let's kind of dissect what this heading means. What is matter? We already studied what matter was. What is matter? What is matter, everybody? Hanji, what is matter? Matter is anything which has a mass and occupies space. I told you everything is connected. Everything is a story. So we are all matter. The table, the TV, the chair, everything is matter, right? And then this chapter says that there are different forms of matter. States mean different forms of matter. Yeah? That's what this chapter is all about. It's telling you that anything which has a mass and occupies space is called matter, and there are different forms of matter. Can you guys name those forms? What are the different forms of matter? It's solid, liquid, and gas, as far as your O levels and A levels are concerned. Other states do in fact exist. Yes, Kashif, Shifa, you all are right. There's plasma, there's quark-gluon condensate, and there's Bose-Einstein condensate. Yes, antimatter, da. We know that there are different states of matter, but largely speaking, in our O levels as well as in our A levels, we only talk about the three states of matter, the three forms of matter: solid, liquid, and gas. And before we dive into the three forms of matter, do you guys want to know how humans came to know about atoms? Do you guys want to know the history of atoms? how we came to know about the atoms. Chalo, let's first talk about how we came to know about the atoms. Well, and I'll connect it to your chapter. Basically, what happened was that humans they always wanted to figure out how we were made, why we were made, and there were so many questions that used to come in their brain. And remember, back in the day, in 4th century BC, 5th century BC, there was no proof. There was no scientific machine to prove anybody's conclusions and da 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 or whatever. Mohammed, I'm not disabling the chat because I like to converse with everybody, because it becomes difficult for me to go over every single message that's been sent to me since Zoom has updated it. So now I have to click on everybody's profile to see the DMs, right? So I think we'll just keep the main chat open. Acha khair. So as I was saying, that we all wanted to figure out what made us. What was the tiniest particle that made us? How did we come into being? What is going on in this universe? Everybody wanted to ponder. It was the age of philosophy. And in this age, there was a scientist, not a scientist, I won't say, there was this Greek philosopher called Plato. Back then, philosophers were in fact scientists, but they had no proof. So, you could just call them Greek philosopher. Do you know who Plato is? Some of you may have heard his name, but most of you don't know who he is. Well, he was a Greek philosopher, and he said that everything, he used to just sit under a tree like Newton. He just used to sit under a tree like Newton, and he used to say everything is made up of 4 elements. It's earth, fire, come on, help me with this. Earth, fire, air, and one more, water. Have you guys watched Avatar: The Last Airbender? A Japanese anime. That's based on Plato's theory that everything, if you haven't watched it, it's fine, but that's like a cartoon. It's everything. He said that everything is made up of earth, fire, air, and water. But people wanted to know more. This was the overall idea, but people wanted to know more. They wanted to know what's going inside the human body. What is, it is earth, fire, air, and water, but there must be something smaller. Then came my beautiful friend called Aristotle. Aristotle came, some of you may have heard, he was also a Greek philosopher, and he came around the 4th century BC. He came around 4th century BC. And you know what he said? Aristotle believed that matter, what is matter, everybody? Anything which has a mass and occupies space. So Aristotle believed that matter is infinitely divisible. Oh my God, sir, such a technical term. What do you mean by infinitely divisible? Infinitely divisible means that if I take matter, I'll explain it. If I take matter, who should I take? Let's take Saf. So he said Aristotle believed that if you take Saf, who is matter, obviously. Why is Saf matter, everybody? Saf is matter because he has mass and he occupies space, right? So Aristotle said that if you take Saf and you start to chop him off into pieces and pieces and pieces and pieces and pieces and pieces and pieces, you could continue to do that forever. Forever. There would be no stop to it. If you start chopping Saf again and again and again, that's what he meant by when he said that matter is infinitely divisible. Infinitely divisible means that if you start to chop off matter, if you start to chop off Saf or whoever, Kashif, if you start to chop them off, you could continue. Sorry, Saf, no offense, please, acha. You can do that forever and ever and ever and ever. And he actually called his theory the continuum theory. This is all extra information. None of this is a part of your course. I'm just going to connect it with your first chapter. So we call this the continuum theory. Continuum theory is derived from the word continuity. You could do that forever and ever and ever and ever. You could continue to do that. But is that true? Can you continue to chop off Saf again and again and again? Will there be no end to it? Then another friend of mine came. His name was Democritus. And Democritus came around the same time, about 5th century BC. BC means before Christ. So he came around this time and he said, hold up a minute, Aristotle. You are actually saying that if you chop Saf off into pieces and pieces, not democracy, Democritus. So he said that if you chop off Saf into pieces and pieces and pieces, I don't believe you can do that forever. तो Aristotle बेचारा बुड्ढा था उस time. Aristotle was old. He was like, oh no, Democritus, I think you can do that forever. That's what I believe with my continuum theory. Democritus said, no, I believe that if you chop sap off into pieces and pieces and pieces, then you can't do that forever. There will come a particle which can no longer be chopped. And you know what that particle is called? He called that particle atomos. That's the Greek word for atom. A stands for not, and tomos means divisible. So he said that this particle can no longer be chopped. That's how the term atomos came into being. But a fun fact. Zainab is saying, oh my god, I got it. Obviously you're going to get it. It's pretty simple. But fun fact, do you know what people believed? We now know that an atom is in fact divisible. There are protons, electrons and neutrons, but we still stick to the same term atom. So do you know who was right back then? Obviously none of them was truly right, but Democritus is more right. There is something called atomos. There is in fact something called an atom, right? The A stands for not and tomos means divisible. But one more thing, everybody. Nobody believed him. Bichara, Democritus. Just like when I say, yaar, please parents, don't go for old teachers with long beards who can just rip you off your money and, So just like I say stuff and which is right, but people don't believe me. Just like that, Democritus said that, don't believe Aristotle. Believe what I am saying. But fun fact, nobody believed him. Everybody believed Aristotle because he was more famous. He was more politically active. He was more famous and whatnot, right? But did any of these guys have proof? Democracy went against Democritus. Did any of these two have proof? Nobody had proof. They were all just sitting under a tree trying to decipher what's going on. Nobody had proof. And the idea of Aristotle prevailed for the next 2,000 years. Literally, for the next 2,000 years, people thought that you could chop sap off into pieces and pieces and pieces, and you can do that forever and ever. Until a person called John Dalton came. John Dalton. You must have studied this you must have also studied this in your elementary classes. John Dalton's atomic theory. You must have studied this. So John Dalton came around the 17th century. He came around the 17th century. And you know who John Dalton was? He was literally an English teacher. He was an English teacher, guys, literally. But he used to be very interested in science. He used to observe scientific works. And near the 17th century, you're going to learn later on in your physics something called as the Boyle's law. You're going to learn something known in the chemistry. This is what you learn in physics in O-levels and IGCSE. And you're going to learn something called moles. These are some of the things that you're going to learn in your O-level IGCSE, chemistry and physics. This is what you learn in chemistry and this is what you learn in physics, right? And John Dalton was sitting and he was observing these scientists, And he said, who came up with the idea of moles? It was Lorenzo Romano Amiedo Carlo Avogadro. Literally, that's his full name. Lorenzo Romano Amiedo Carlo Avogadro. Something known as the Avogadro's constant. You must have studied. He was also a scientist. Yes, Avogadro. His full name is Lorenzo Romano Amiedo Carlo Avogadro. That's his full name. Not avocado, Avogadro. Sir, you've actually memorized his name. I know it by heart. He's my friend. Khair. So John Dalton was looking at these two scientists and he said, Zainab, you're going to love moles after we are done with it. Don't worry about it. He said that the only way that their discoveries can be true is if, ting, 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 is if Uncle D was right. You know who Uncle D is? Uncle D is Democritus. So John Dalton said, hey, the only way that their ideas can be true, the only thing that can explain their ideas is the fact that matter is not infinitely divisible. It's the fact that there is and there must be something known as atomos. He called it atom, but because he was an English teacher, but he said there must be something known as an atom, And nobody believed John Dalton even. But he went to the scientific committee. He had sources, he had links. That's when you realize that even in the 17th century BC, if you had, not BC, but even in the 17th century, if you had links and if you had connections back then, things could sound really good and in your favor. So John Dalton went to the scientific committee and he proposed something known as the atomic theory, John Dalton's atomic theory. And because he had friends there, everybody believed him and his theory was approved. And we followed that theory till the 1900s, literally till the early 1900s. And even now in basic studies like we are doing now, we still follow his theory just because he was very resourceful. So he had connections in the scientific committee. And you know what he proposed? He came up with certain postulates. Postulates are like points. He came up with certain points and he told that to the scientific committee. And he said, yeah, I'm copying from Democritus. Democritus said the same thing, but I'm going to say it in a more fancy way. So he said that, hey guys, listen to me. Any pure substance, this is where your chemistry starts from. So he said that any pure substance found in nature, I hope you guys are also jotting this down, found in nature, chemistry is cooked, yeah, any pure substance found in nature is made up of what? Is made up of atoms. Yeah, Democritus was in fact a lonely person, bichara, dil khafa ho gaya mera. So that's what he said. He said any pure substance found in nature is made up of atoms, right? And if I show you some pure substances, you'll see them. We're going to learn what pure means later on in our course content. In this particular chapter, in fact, we'll learn what pure means. But for now, I'll show you pure substances. Voila. These are all pure substances, everybody. So, your periodic table, right? So, these are all pure substances. What are they going to be made up of? They're going to be made up of atoms. Magnesium is going to be made up of atoms. Vanadium is going to be made up of atoms. Iron is going to be made up of atoms. Copper is going to be made up of atoms. So that's literally what he said, that any pure substance. What do we mean by pure? I'll tell you that later on because it's a story. I don't want to destroy the story. But for now, just realize that just believe me when I say that all of these substances are pure. So all of these substances are going to be made up of what? They're going to be made up of atoms. That's literally what he said. And then he said that the second point that he proposed was that atoms of a given substance, of a given pure substance, are all the same or are all of one type. Or you could also say identical. I don't like to use the word identical. I'll tell you that later on. But he said that atoms of a given pure substance are all identical. What did he mean by this? Well, identical spelling is wrong. It's not an English class. Please cut me some slack. Identical. Now is it fine? Okay, fine. So he said that atoms of a given pure substance are all of the same type, aka they are all identical. What did he mean by this? Well, he zoomed into lithium and he said, hey, lithium is made up of atoms, but it's going to be made up of lithium atoms only. Beryllium is going to be made up of beryllium atoms only. Magnesium is going to be made up of magnesium atoms only. Vanadium is going to be made up of vanadium atoms only. See how chemistry is forming? Iron is going to be made up of iron atoms only. Copper is going to be made up of copper atoms only. So the first thing that he said was any pure substance found in nature is made up of atoms, and atoms of a given pure substance are going to be identical. So if you talk about copper atoms, so copper is going to be made up of atoms, but it's going to be made up of only copper atoms. If you check about iron, please don't go forward to compounds and mixtures. Please, I'm going to disable the chat. Please, come on guys. Let's be a little profesh. Can we be a little profesh and focus on what I'm saying? Yes, please. Or else I have to disable the group chat. Okay, I'll have to disable it. Okay, khair. Chalo. So they're made up of vanadium is made up of vanadium atoms, iron is made up of iron atoms, and da da da. That's the second thing. Second thing that he said. And you know what these two gave rise to? These two gave rise to the definition and the idea of an element. That's how elements were discovered. You know what an element is? Literally combine these two definitions, that's an element. So an element is in fact a pure substance found in nature which is made up of identical atoms. Made up of, and I won't use the term identical, I'll just replace it with the same type or one type, same or one type of atoms. And I'll tell you why I'm not going to use the word identical. Although in your course in O-level IGCSE you could also use the word identical, but I'm not going to use it because it's not correct, and I'll tell you why it's not correct in chapter number 2. So bear with me. Somebody remind me in chapter number 2 why I'm not using the word identical. Please, somebody just remind. ठीक है? So element क्या है? It's literally a pure substance found in nature that is made up of atoms, but identical atoms. Not identical. I'm not going to use the word identical. I'm going to use same type. One type. It's made up of the same type of atoms. So lithium made up of same type of atoms, same type of lithium atoms. Sodium made up of the same type of sodium atoms. Magnesium made up of the same type of atoms, which is magnesium atoms. Calcium made up of the same type of atoms, which is calcium atoms. Right? That's literally the definition of an element. आपका syllabus शुरू हो गया बेटा. Element की definition. An element can't be broken down into smaller pieces. You can't chemically or through electricity, you can't break an element, you know. It cannot be decomposed. You can't decompose an element. Cannot be broken down into something smaller, you know. I'm not talking about the atom. I'm just talking about, you know, you can't go from sodium element to something smaller, you know. You can, but then it won't be sodium. Realize, in fact, you guys are right. You can go to something smaller, a smaller atom. You can take away the proton somehow and you can go to maybe helium or whatever, but it won't be sodium. So that's what an element is. You know, it's a pure substance which is made up of one type of atoms. And fun fact, guys, that is the reason why the periodic table is known as, please, aanke phaad ke dekhe. Look at it. The periodic table of, please everybody write it. The periodic table of elements. So if I ask you, why is boron an element? 2 reasons. Number 1, it's a pure substance. And number 2, it has one type of atoms. Use the word one type instead of identical. So one type of atoms. Why is helium an element? Because it is a pure substance. What is meant by pure? I'll teach you that in a while. And it is made from one type of atoms. Literally. And that's what John Dalton said. Literally. Why is neon an element? Come on. Why is neon an element? 2 things. Why is neon an element? Why? Okay, I'll enable the chat, please. But try to just follow me. हाँ? बाद में गपशप लगाते हैं ना. आपस में लड़ क्यों रहे हैं? छोटे बच्चे हैं. So why is neon an element? 2 things. Number 1, it's a pure substance. What do we mean by pure? I'll teach you that in a while. But it's a pure substance. And number 2, it's made up of one type of atoms or the same type of atoms. It's better to say one type. One type of atoms. Makes sense? Yes? Easy? And then John Dalton said something strange. He said, if I take 2 elements, if I take 2 or more elements, he took sodium and he took chlorine. And he said, if I take 2 different elements and I somehow chemically combine them, it's going to give me something known as a compound. So he said, what's a compound? What's a compound? It's literally a pure substance. Sir, compound be pure hai? Yes. What is meant by pure? In a while, guys. Just relax. Stay with me till the next class. I'll teach you what pure means, and then you'll also know it's not the pure that you use in your English, you know. It's something else. So compound is also a pure substance which is made up of when 2 or more elements chemically combine. What is meant by chemically combine? हर चीज में what पूछे, why पूछे. What is meant by chemically combine? Chemically combined means that there's literally a chemical reaction that takes place. Literally a reaction taking place. And how does that reaction take place? That you're going to study in moles and stoichiometry. The moles and stoichiometry, you're going to learn what chemically combined means. For now, just realize it's chemically combined means that whenever new things are going to be formed, whenever there's a reaction taking place, right? So for a compound to form, you need 2 or more elements. And fun fact, guys, sodium, do you know what sodium is? It's a highly reactive metal. It's very reactive. If you put it on the palm of your hands, if you put it on the palm of your hand, it's gonna burn through it. That's how reactive sodium is. That's why you need to store it under a layer of oil. Literally. That's why you need to store sodium under a layer of oil, because of how reactive it is. If you put it on the palm of your hand, it'll burn through it. And you know what chlorine is? You know what chlorine is? Chlorine is a poisonous gas. It was used in World War I as well. I think Germany used it. I think either Germany used it or Britain used it. Either or. I think Germany used it. One of them used ammonia and the other one used chlorine. Now I'm getting confused which of these. But it's a poisonous gas. Literally. Wait, Saf, hold on a minute. I'll give you a chance to speak. Huh? Just give me a moment. So it's a poisonous gas. Poisonous gas, right? And NaCl, do you know what NaCl is? It's literally the edible salt. The salt that you eat in your day-to-day life. The salt that you eat in your biryanis, the salt that you eat in your, in your chicken, and that you use in your kadais and whatnot. So that's literally edible salt. So realize that when substances are chemically combined, they have totally different properties from the elements that they are made. So NaCl is made from two elements. It's made from sodium and it's made from chlorine. But you need to understand that it has different properties. That's why it's a compound. Different properties than its elements. How beautiful is that? If this was toxic or reactive or poisonous, it would have killed us. Although it's still slowly killing us. Too much namak is causing blood pressure and whatnot. But yeah, that's the reality of life. Now, that's what he said about compounds. So he said two things. He effectively said two things. He said elements. What are elements? They are pure substances which are made up of identical atoms. But I'm not going to use the word identical. I'm going to use one type or same type. So made up of the same or one type of atoms. What is meant by compounds? And where can you find elements in your periodic table? What is meant by compounds? Compounds are also pure substances, but they are formed when two or more elements chemically combine, which means something new is forming. Something with new properties is forming. Just like edible salt. Chemically combined. Any questions up at this point? कितना मजे की चीजें हैं यार. It's so beautiful. So beautiful. Just like if I were to talk about another compound like hydrogen. Hydrogen is a flammable gas. It's a highly flammable gas, right? And oxygen is something that we inhale in our day-to-day lives. And when hydrogens and oxygens combine, they give you something known as H2O, which is what? That's water. So water has different properties than its elements. That's a compound. Why is water a compound? Because it's made up of three elements. Yes, guys, water is made up of three elements. Somebody's gonna say, yes, sir, it's made up of three elements because you see, you have two hydrogens and one oxygen. No, you dumbo jumbo. It's made up of two elements. Element uno is hydrogen. Element dos is oxygen. Yes, there are two atoms of hydrogen combined with one oxygen, but the element is hydrogen. So realize it's a compound not because it has three elements, but it's two elements chemically combined. Students tend to confuse atoms with elements. Elements are made up of atoms. So here you have two different elements. One is hydrogen, one is oxygen, and hydrogen in fact has two atoms combined with oxygen. That's it. Easy peasy. Easy, guys. Asan mushkil. Asan mushkil. I've enabled the chat, so you guys can... Oh, I've not enabled the chat. Sorry. Now you guys... I've clicked on no one. Sorry, guys. Now you guys can chat. Easy? Yes, yes. Yes, somebody's DMing me, sir, मैं कसम से और बच्चे ला रहा. Oh, that's awesome. Thank you for promoting me. Yes, let's go. Let's go. Easy peasy. Now, a couple of things that you need to keep in mind. Something that John Dalton missed on is called a molecule. And you'll learn about molecule in chapter number 3. You'll learn about molecule in chapter number 3. For now, I'll just define it. Molecules form when one or more same type or different type. Same or different Same or different लिख लेता हूँ. Wait. When one or more same or different atoms chemically combine. Or you could say combine through covalent bonds. Covalently combined. What is covalently combined? You learned that in chapter 3. Please highlight it. See, chemistry is very much interconnected. So if I'm writing covalently bond and I'm saying, hey, just trust me, I'll talk about this in chapter number 3. I will revise the definition. But for now, realize that a molecule can have one or more same or different atoms covalently combined or chemically combined. This means that there must be a reaction. Now, let's just look at these 3 definitions and try to understand it more with more conceptual clarity. Walaikum salam, Anas. What's up, kiddo? Acha, with more conceptual clarity. My question to you guys. NaCl. Now you guys have to answer. NaCl, is it a compound or is it an element, or is it a compound or element? It's obviously a compound, so I'll write C in front of it. FeCl3, is it a compound? Iron chloride, is it a compound or an element? It's obviously a compound. Why? Because it's a pure substance made when two different elements chemically combine. It's a substance which is made, it's a pure substance made up of two different elements chemically combining. Chemically combining, which means this is something new. Iron is something different, chlorine is something different, and this is something new, right? My question to you guys, O2, but before I talk about O2, sodium, is it a compound or is it an element? Sodium, the symbol for sodium is Na. That's the symbol. That's written in the periodic table. So it's obviously an element. Why? Because it's a pure substance made up of one type of atoms. Easy. Yeah. Easy peasy. Asan. Okay. One more thing. Let's talk about oxygen. O2. Is O2 an element or is O2 a compound? Is O2, forget about molecule for now. We're going to look into molecule in chapter number 3. I just wrote the definition here. But between compound and element, what is oxygen? Remember, guys, some of you tend to mistake this. Oxygen is also an element. Please. Oxygen, hydrogen, nitrogen, chlorine, fluorine, and the examiner is testing this a lot. It's also an astatine, tennessine, TAT2, I2, TS2, they are all elements. Why? Some bromine as well, Br2. Why are they all elements? Because realize you have the same type of atoms. Dekho, hydrogen is H2. Because some of you guys have studied chemistry before. Please forget all the chemistry that you've studied up until this point. Please forget about it, right? Because I'll teach you new chemistry. Because your teachers, they tend to confuse you guys in things. I'll give you clear conceptual understanding. Okay, what did I say? What is an element? Always go to the definition. What is an element? An element is a pure substance made up of the same type of atoms. Hydrogen has two atoms, but are they not the hydrogen atom? Is it not the hydrogen atom? It is. Be it 2, be it 3, be it 4, I couldn't care. I don't give a shit, It's the same type of atom. The atom is still hydrogen. Nitrogen, although it has two atoms, but it's still the atom of nitrogen. An element just means it has the same type of atom. And it is the same time. There are two atoms, but they're both of nitrogen. There are two atoms, but they're both of chlorine. There are two atoms, but they're both of fluorine. So this is not a compound. It's also an element. Yes, those of you who studied chemistry before, they are also molecules. So a particular thing can be an element and it can also be a molecule. And similar is the case with compound. And the differences between these three are going to be further clarified in chapter number 3. I can't go ahead, but it'll further be clarified in chapter number 3, which is bonding. Do O2 properties change after bonding? We'll talk about bonding later on, kiddo. Forget about bonding. Chapter 3 mein padhenge na. But for now realize, question. H2, is it a compound or is it an element? Compound or element? Why is H2 not an element? Why is H2 not a compound? Why is H2 not a compound? Because it is not two elements chemically combined. It's just a single element, which is hydrogen. Yes, there are two atoms, but it's still there are two atoms. You are right, but it's still the same type of atom. It's a single element. Element to hydrogen here. There are two atoms of hydrogen, but it's hydrogen. So it's not a compound, because compounds need to be two elements, two or more elements chemically combined. This is just a single element chemically combined with its atoms. So it's also an element. Yeah. Yes, Hava, H2. H is not H1, Kashif, it's H2. Hydrogen exists in the universe in the form of H2. Hava, there's no such thing as H. H never exists. It's very reactive. It always exists in the form of H2. Nitrogen never exists like N. It exists in the form of N2. And 78% of your air is in fact nitrogen. So I just wanted to clarify the differences between elements and compounds. Molecule की definition मैंने लिखी है, but I'm not going into the detail for molecules because we'll learn that later on in chapter number 3. Done, sir. So अभी तक हमने क्या सीखा? हमने सीखा elements are pure substances made up of one type or the same type of atoms. Compounds are also pure substances made up of two or more elements chemically combined. Fun fact, everybody, is carbon dioxide a compound or is it an element? Is carbon dioxide a compound or an element? Is SO2 a compound or an element? It's obviously a compound. It's not an element, because for an element, there must have been a single type of atom. Here, in carbon dioxide, there's carbon as well as oxygen. So there are two elements, two different elements. There are two different elements, sulfur and oxygen. And yes, you could also have defined compound as a pure substance made up of two or more different atoms chemically combined. Because in fact, you realize that if there are two, realize a couple of things. That if there are two elements chemically combined, they must have different atoms as well. So if there are two or more different atoms chemically combined, that's also what a compound is. You could either define it like this, or sometimes in MCQs, the examiner defines it like this. It's the same thing. If there are two or more elements chemically combined, so two elements means that there must be two different atoms as well. That's it. Write it with yourself. Two elements means that there must be two different atoms. और तीसरी बात जो डॉन डाल्टन ने कही थी, वो उसने सिंपल बात कही थी कि atoms can neither be created nor destroyed. And this is going to be used in chapter number 4, which is moles and stoichiometry. चौथी बात उसने कही है, I had taken notes properly. Have taken, sorry. Okay, great. Sir, the wordings of these definitions can be written in the exam. Sir, the wording, these are the wordings. These are the wordings, guys. Please don't write wordings on your own. These are the wordings. You know, compound, pure substance made up of two or more elements chemically combined. Or you could say compounds, pure substances made up of two or more different atoms chemically combined. You don't need to write the word different with elements, it's fine. These notes will all be uploaded onto the portal. So once you register, or this is a demo going on, right? So hopefully we'll have a lot of kids this time. I hope you guys are spreading the word, yeah? So every student has their own personalized portal. All the notes, everything is going to be added to the portal in a very orderly manner. Done, guys? Alina is saying, sir, if atoms cannot be created nor destroyed and we have learned about their origin, doesn't it contradict? It does contradict the whole thing, Alina. But now you are going to talk about this day and age. So in this day and age, Alina, atoms in fact can neither be created nor destroyed. And Alina, you also, this is something very complicated, but you also have said this in physics. Don't you say this in physics, that energy can neither be created nor destroyed? Where did the initial energy come from? It must have come from something, you know? Like people say, I told you about the unified force idea, that everybody thought that there was energy, which was unified force, and that energy was in fact converted into atoms, you know? So it's a very complicated. Atoms can be converted into energy. Yes, they can, Ahmed Shafiq. Because if you take a block of wood and you start burning it, you are actually converting its atoms into energy. E equals mc square. the students have started showing interest in actual chemistry, but some things, I tend to not discuss, or I tend to lie about, because they're not a part of your course. So I tend to just lie about it to satisfy your queries. And if you're actually interested, you can go on to Google and search about it more. But don't contradict practical chemistry with O-level IGCSE chemistry. It's very different. That's why I always say don't take help from ChatGPT in chemistry, because there are a lot of exceptions in chemistry, and you guys are going to fumble big time, because the ChatGPT is going to tell you those exceptions which are not going to be a part of your course. Can we make a nuclear bomb? Pakistan has already made it. Okay, last thing. About 1820, last bas aakhri baat. This has been removed from your course. Please realize that it's been removed from your course, but I'm going to discuss it. So in 1827, there was this guy named Robert Brown. I'm going to quickly discuss it. Robert Brown was a botanist. You know what a botanist is? Botanist. Biologist ki tarah hota hai. Botanist. It's like a biologist. Not Oppenheimer, Robert Brown. RB. Robert Brown. He came about in 1827, and he saw that on water there were pollen grains which were moving. He saw that on water pollen grains were moving. And he got scared to his core. He was like, oh my god, mom, polar grains are actually living things. I thought that they're not living things. So pollen grains are living. And he ran home. He cried in a corner. He said, Suleiman, pollen grains are living. And I said, oh no, you dumbo. Pollen grains are not actually living. But what happens is that the smaller particles, which are the water molecules, H2O, smaller particles, they are continuously moving in a zigzag pattern. And because they are continuously moving in a zigzag pattern, they are colliding or bombarding with the pollen grains. And that's why the pollen grains are moving in a zigzag pattern, you dumb person. So I told him, hey, smaller particles actually bombard. Bombard means hit, collide. Bombard the larger particles. And that's why the larger particles move in a zigzag pattern. That's it. I'm going to only explain this part, because that's all there is to this portion. And it's now been removed. Even in 2020, for 2025, it's been removed. So he just said that smaller particles bombard the larger particles, and that's why you can see the larger particles moving in a zigzag pattern. That's what I told Robert Brown. He didn't believe me to much extent, but later on he realized that I am right. So their smaller particles are continuously in a random motion. I told him that these H2O particles are continuously in a random motion. And he asked me, sir, why are these smaller particles continuously in a random motion? I said, wait for the next chapter, which is states of matter. Wait for states of matter. I'll tell you why they are. That's a kinetic particle theory. कल से पहला chapter शुरू होगा. Sorry guys. पहला chapter का हमने 2-3 बातें कर ली हैं. But, so the larger particles are visible to the human eye? Yes, Arush. That's why he thought pollen grains were living. But in fact, they weren't. They were just being hit by the smaller particles. The smaller H2O particles. And you will see this experiment in physics called the smoke particle experiment. Sir, आपके lecture repeat पर देके हम क्यों भाई इतना प्यार? So that's what you learn in physics, smoke particles. You take smoke particles and you see them moving. Why are smoke particles moving? Because they are larger than air particles. So the smaller air particles hit or bombard the smoke particles, which you can see. So you could realize the smaller band. But why don't these atoms move in a curve? It's because of something known as the kinetic particle theory and something other than the course. तो आप research कर सकते हैं इस पे if you want. अच्छा खैर, so in summary, one more thing. Somebody asked a beautiful question. किधर है? Muhammad Ahmed said, sir, if atom is the smallest particle, then what? Isn't electron? I literally told you that this definition is flawed. Saying that as atom is the basic unit of matter is flawed. We know that atom is not in fact indivisible. We now know. If the MCQ says, is atom indivisible? No, it's not. Because it is made up of protons, electrons, and neutrons. So you're not going to say atom, but that's how it was discovered. That atomos, not divisible. But now we know it's particles even smaller than the atom exist. But one more thing, guys. बस आखिरी बात बताने लगा. Last thing. ये बहुत अच्छा सवाल इस बच्ची ने पूछा है. बच्चा है कि बच्ची है? Let me see. अहमद ने सवाल पूछा है कि सर कि यार सर क्यों ये खजल ख्वारी कर रहे हैं? Why are you doing so much effort in teaching us that atom was discovered like it's not divisible atomos and whatnot, and you're still defining it as the basic unit of matter? Why aren't you saying that protons, electrons, and neutrons are smaller, and why aren't you calling them? There's a reason for it. There's a reason why scientists and even Cambridge has not changed this definition to much extent. Why? I'll tell you the reason. देखिए, if you take a block of sodium, I'll tell you, if you take a block of sodium, if you take a block of sodium is made up of 11 protons. Sodium is made up of 11 protons. This is a very beautiful concept. Even your teachers don't know this. Sodium is made up of 11 protons, right? If I say what is the smallest particle that makes up sodium, what is the basic unit of sodium? What is the basic unit of sodium? We say atom. And Ahmed might say, sir, my God, why aren't you saying proton, electron, and neutron? Because, Ahmed, now listen to this, it's beautiful. Because, Ahmed, sodium has certain properties, right? It's a very reactive metal, it's blah, blah, blah. If you put it on the palm of your hand, it'll burn through your hand and whatnot, right, Ahmed? Right? But the smallest particle which will contain the same properties as this block of sodium is gonna be the atom of sodium. A proton, yes, you could have a smaller particle than this. You could have a single proton, but then this single proton will not contain the properties or will not exhibit the properties of sodium. That's why till date we say that atom is in fact the basic unit of matter. An atom of an element is the smallest particle which will show the characteristic properties, which will show the properties of the element. So atom is in fact the basic unit of this element. It's the smallest particle which will show the properties of sodium. Ahmed, try to digest it. I will repeat it, Arush. I will repeat it. Listen. Sodium has certain properties. And the smallest particle which will show these properties of sodium is called the atom of sodium. That's the small. A single proton is smaller than the atom, but it will not show you the properties of sodium. That's why we say the basic unit of sodium which will show the properties of sodium is the atom of sodium. इसीलिए आज तक हम क्यों कहते हैं an atom is the basic unit of matter? There's a reason for it. हाँ, लेकिन ये बात कहना कि atom is not divisible is now wrong. We are going to say the atom is in fact divisible. Electrons and protons are same in all atoms. No, they're not same. They're different. In sodium there are 11 protons. In magnesium there are 12 protons. हाँ, protons, electrons are the same. They don't differ. It's the same. Proton ही होता है, कुछ और तो नहीं होता. Right? It's proton. It's a positively charged particles. You'll learn more about that later on. But does it make sense? Now you have to ask your teachers this. This is my challenge. Your teachers, you have to ask them, sir, why do we still say that an atom of an element is the basic unit of that element? Why do we say that? I'll also write it for you. If you want the bougie definition of an atom, it's the basic unit which will show the characteristic properties. If you want the bougie definition, which will show the properties or the characteristic is like the properties relating to sodium. So characteristic, please forgive my spelling, properties, which will show the properties, I'll add them in the brackets, so which will show the properties of that element. That is what we mean by an atom of an element. Makes sense, guys? So this is a confusion. When I was in O levels, I also used to think this. Oh my God, if we are saying atom is the basic unit of matter, but there are protons, electrons, and neutrons. And then later on, I figured out that, hey, an atom is in fact the basic unit. An atom of sodium is the smallest particle of sodium that can exist. It's the smallest particle which will still show you the properties of sodium. Anything smaller than that can exist, but it will not show you the properties of sodium anymore. It'll show you the properties of something else. Now did it make sense when I said that an atom is the basic unit of matter and cannot be seen with the naked eye? Now you guys believe me when I say that atom is the basic unit? Nowadays in 2022, till the 2022 syllabus, we used to say that atom is indivisible. We used to say that atom cannot be divided till the 2022 syllabus. But now 2023 onwards, we've said that atom can be divided into protons, electrons, and neutrons. It's not the smallest particle, but it is the basic unit of matter. Makes sense, guys? Love you all. Keep on talking about King Khan, and hopefully in the next 4 days the classes are gonna be only tomorrow we're gonna start the proper course. बस आज के लिए इतना काफी था. Definition of molecule, just write the definition, but don't try to use your brain a lot on this definition. So I hope it made sense, everybody. Did it make sense? Make sense? है? आसान